Thank you, Masuma, and thank you all. A very good morning to all of you.
Yes, ma'am. Yes, ma'am. You can proceed, ma'am.
Yeah. So this two-day international online workshop on computing trends transforming 2020 is organized by School of Computer Science and Engineering along with the VIT Alumni Association, and Dr. R. Maheshwari and Dr. S. Rajkumar sir, they are organizing this one. And like the participants list is also very promising, close to 300 plus participants, and few of you are yet to join. So we understand like some more people will be joining. The speakers are also great personalities who are alumni of VIT, and they are in big companies like Intel, Barclays, and all. So to come about the technologies what are being offered, nowadays, the world is just stepping into the complete new normal after this pandemic. Our priorities might be definitely changing, and say what we thought like something impossible sometimes before have become a new normal today. So one such example is holding any workshop online completely. That would demand a huge arrangement, setup of say tools in all the client's machine, and then a separate infrastructure for that. And we could never have imagined that this has become so handy and so easy nowadays. So you mean any tool, Gmeet or Zoom or Skype or anything, no? Any system will have minimum 4 to 5 of these tools. So they are open source and they have made your meetings very user friendly. And we could see like a lot of family meetings are also convened in Zoom. So this is one thing which has made the technology handy and easy to use for anybody, even a person who does not have a computer literacy. And same way we have got in pipeline a lot of technologies in line for that. Few to name will be your blockchain technology, artificial intelligence, cyber security, and IoT. If people could tell like they are going to rule this cyberspace in future, in near future, this would never been a wonder. Say this artificial intelligence is going to rule like anything. I could tell a small lifetime example. Say I know a grand lady, like she's an old lady, and very recently we bought her a gift like a Geo phone, which is very cheap, kind of that, and you get 2 GB of data every day. She does not even know how to make a call using that. Just a button press is not even her choice. So green button means make a call, red button means stop a call, and we used to give her some icons. This icon, this girl means this is your daughter, this boy, this small guy means this is your son, kind of that. That was the symbol book we referred to her. And now like she's playing and she's completely into the YouTube, a kind of addiction. Can you develop an addiction at the age of 65? The answer is you can see her. She is wondering in the morning, no, automatically devotional songs are playing. In the afternoon, automatically recipes are playing. How come this is possible? Everything is purely an artificial intelligence. The recommendations, one video you play, and in what time you are playing. So all this is what a technology should be. This is how a technology should be. It should reach the common man. It should not be like a big buzzword, or it should not be a scary thing. So artificial intelligence is though it's from 1970s, now only it has brought seen its way into our everyday lives. And this is a very small, petty example. And you could be knowing still more better examples. And now like Google, you just present to it some 50 photos of yourself. It is arranging according to your age, and it is developing a video. So it is doing age calculations also. Sometimes there are like some precision mistakes, but anyway, 80% or 85%, the age guessing made by Google is perfect. So like it is saving the time. So can you guess of something which is possible close to this one? It's purely Face App. Face App has been very popular. Some 4-5 months back, everybody was playing with Face App, and they are posting in WhatsApp status or anything like DP photos. They have kept the Face App photos. So that is one component of artificial intelligence. Though it looks like funny or entertainment, there are many useful applications pinned along with artificial intelligence. Lots and lots of things. And now people are trying for reincarnation, rebirth. Okay, we think like Maru Janma. We talk like that, reincarnation. We lose our favorite, very close to heart people. And now through this technology, can you make us believe like they are still living? You can go and talk with them. They will give the same kind of discussions. They will give the same kind of performance. For example, SPB. So he was a very great singer and we recently missed him, lost him. So by reincarnation, would you be able to have some manifestation of SPB? That is one another experiment going on. Any, say, suppose your grandma or your uncle is very close to you. So his profile is manifested. So it will always behave, it will always be in that manner responding to you, be friendly with you. The same orientation of thought process is mimicked. So can you think of customers sometimes back? And blockchain technology is yet another very powerful technology. Like kind of Bitcoin currency is embedded there, and anything from supply chain, from the point it is manufactured and it is reaching the customer's hand, everything is transparent. So there is no point of say no way or no point of cheating or no point of say doing any manipulations in that. And cyber security, no words to mention. You get new malwares reported, concentrated towards your PCs and focused towards your Android. You get a lot of cybersecurity threats, the same proportion, at the same speed. Your cybersecurity solutions are also growing. Okay, biometrics, it's a very vast field, and IoT is very powerful because with those sensors and with those devices, you can do wonders. Okay, you can do wonders. You can keep them, say, how much, I mean, like your entire lifestyle, you can do a package within these four technologies. And these are all from computer science majorly, and that is one important aspect. And nowadays, you have the cyber physical system, which is a superset of Internet of Things. Okay, so entire cyber, the communication, the control, the computing, all together taken care by the cyber physical system. And there the security is predominantly important. And now it's the very next thing to move on to the next stage in life. Because digital natives, we ma'am and sir and all, we are all digital, I mean like natives, my immigrants, we were not digital and we moved into the digital space. You people are digital natives, you are born. And what is the next step is a big question. And we would find answer in this workshop and all those things. And we understand this is a very wonderful platform to get connected with great personalities who are your alumni. So there are two things you can take up. One is you can establish a good connection with them, and then you can be inspired by their speeches and know or exposing to the technologies. Another one, in due course of time, we want you also to be associated with us in the same manner, become great personalities and coming back to our own VIT and contribute and inspire people. So with this, I take this opportunity to thank all the coordinators, organizers, and then wish you good luck. Thank you, ma'am. Thank you, sir.
Thank you so much, ma'am, for giving us eye-opening examples, which are very impressive. Thank you so much, ma'am. Thanks a lot. Today's session is held on full stack IT development with AWS, where we would learn how to use various AWS services to develop a full stack IT project. I would take this opportunity to give a brief introduction about our resource person, Mr.Anamay. Anmay is a computer science and engineering graduate from Vellore Institute of Technology belonging to the batch of 2016. He has done full stack IT projects, gaining experience in fabrication and automation, developing prototypes of autonomous robots and drones. He has an Indian patent granted for a technology crucial for autonomous drone package delivery. He did research on federated learning by being an intern at Intel for 6 months. He was also an intern at ADE DRDO, wherein he optimized a MATLAB application for aircraft QAC. Thank you so much, Mr. Anmay, for being a part of this conference. I would now like to give you the control so that you can walk us all through the much awaited IT development experience. And once again, welcome you all.
Hello, everyone. Good morning. So Thank you, Maheshwari ma'am, for giving me this opportunity. I would like to thank all the VIT faculties and staff, senior members for the amazing experience that I had of my education at VIT. And thank you, Geeta ma'am, for the introductory session that was really enlightening. And so with this, I would like to start my presentation. So just give me 2 seconds, I'll share my screen. So could you please confirm if you are able to see my screen?
Yes, it is visible.
Okay, thank you. So, hi, my name is Anamay Pratik, and welcome to the session on AWS IoT development. So this session is a high-level overview of all the components of AWS IoT offering. With millions of Internet of Things devices that are being added to the market every year, we want to be prepared to benefit from what some are calling the fourth industrial revolution. Some of the major topics that we will cover include IoT risks and responsibilities, leveraging custom software for IoT devices, AWS IoT services to help us build and secure applications, and how we can integrate our IoT applications with other AWS services. By the end of this session, we will know enough about the Internet of Things and AWS IoT service suite to plan our projects in IoT application. And we will also gain a lot of insights regarding all the IoT terminologies. So this session requires a little bit of familiarity with cloud computing and potentially a little bit of knowledge about AWS itself. So after this session, I'm sure that the participants, the students will feel very comfortable in going ahead and developing IoT projects with AWS services. I hope this session is helpful. And with this, I'll start this session. So in the first section, we will be looking at what is AWS IoT and why do we need it. So we'll be covering and going over a bunch of different things ranging from basic understanding of IoT in general to identify capabilities of AWS IoT services and how to use the suite to our needs of of developing applications, as well as adding security and functionality to both applications and device themselves. Okay, so let's take a specific look at the overview of the first section. We'll start by looking at what is Internet of Things.
Sorry for the interruption, Nami.
Yes,
The slide is at the first one.
yeah,
Visualizing IoT, am I right?
yes. So I am moving ahead. So this is just like a glimpse of what all we'll be covering as we proceed further. So, okay. So these are the things that I we will be covering. So first is IoT risks and responsibilities, leveraging custom software for IoT applications development, AWS IoT services, and integration of IoT applications with various other AWS services. Prerequisites for this session are a bit of knowledge in cloud computing and a bit of familiarity with AWS platform. So what is AWS IoT? So in this session that will, in this section specifically that I'm starting now, we'll be going through the in general understanding of IoT and the capabilities of AWS IoT, how to apply the AWS IoT services for our projects and the security and functionality aspects. So these are the first section things which I'll be going on or going through. Hello.
Yes, your screen
So,
sharing stop now.
so I'm so sorry. Actually, my network just got disconnected. I am having some issues. I'll just start it again.
Okay, no problem. Yeah, it is visible now. You can proceed, please.
Okay, okay. Thank you. So we'll start with what is Internet of Things, and let's take a quick go through the definition. So the network of traditionally non-network devices like teapots, dishwashers, or vehicles that contain the hardware and software to connect with to contain the that contain hardware and software required to connect with other devices and exchange data. So this can be said as the formal definition of Internet of Things. When we are talking about what people use in words of IoT, but let's take a look at the visual to help us get a better understanding. So visualizing IoT. So all the devices that were mentioned in the definition. Now these are traditionally non-network things, and so traditional computers or servers may be, or even cell phones, as we think of them in the modern age. But something like a door with an internet connected lock, or a car with maybe a speedometer in the long run, or a robotic arm that shares information would eventually be sent that information would eventually be sent to a network, or maybe some hardware in a factory that we need to construct different things inside of a manufacturing environment. Now each of these devices would probably send or receive bits of information, and because of this they would need to be networked in some way. Now these devices might just be networked in a way that's with a local application or a local device. So, for example, an instance of manufacturing equipment, maybe it doesn't eventually connect to the entire internet, but it does communicate within the manufacturing environment and communicate to other local devices or local applications. However, for many other IoT devices, they will eventually connect to some sort of application server through the internet and then maybe be processed in different ways. So for the example of locking door for IoT device, it might connect to some sort of mobile application that would allow to lock or unlock your door. For the car, maybe we would send the speedometer information to an application that allows us to process that for insurance companies. And this actually happens frequently if we sign up or opt into these programs. We might be eligible for reduced rates if we are a safe driver and we are driving within the speed limits of the area and the required and following the required rules of the road. Now let us take some time to understand the segments of IoT so we have a better understanding of not only these individual devices and how they might work, but general segments that the entire IoT market might have. Now, the first one we have already discussed a little bit is vehicles. You'll frequently uh, will frequently notice that in our cars and devices, inside of that, we will have units that will be sending and receiving information for maintenance and other purposes, but also in things like trucks or 16 wheelers, we will have lots and lots of information that they send back and forth, both on the places that the goods are to be transported and also to the maintenance information of those large vehicles. In addition, there will also be IoT used in agriculture and in security to do monitoring and progress of growing plants and also just to keep track of different location and try to make sure that no intruders are coming into those locations. We will also frequently see these in medical industry. That is, IoT devices will be used in hospitals to monitor various devices that are in those hospitals. Now, frequently, we will see that we have a bit of responsibility on us when we are using IoT devices in medical domain. And we will talk more about these risks later on. Now, in addition to medicine, let us see the applications in the domain of buildings, cities, and infrastructure. Now, on the door lock in our home that we talked about earlier. However, they will also frequently be used to try to save things like electricity and power that might be used for heating and cooling when there's nobody in the building or the temperature inside and outside of the building is fluctuating a little bit differently. Now to kind of lead into our next segment, here the utilities will also use information and use IoT devices to help monitor the progress of the various utility networks. Now, all of these are just a few segments Hello, could you please confirm if I'm audible?
Yes, sir, you're audible.
I'm so sorry. I think I got dropped off.
You please share your screen.
Yes. Okay, so now that we have a high level understanding of how IoT works and some segments that IoT falls within, let's take a look at some specific terminology that we will need to know when we are working with the Internet of Things. So let's get started by talking about smart and connected devices or things. Now, this is kind of a more generic term that could apply to anything from watches to thermostats to dishwashers. But when we talk about IoT in context of AWS later on, it is specifically AWS IoT things, which include the devices that are mentioned that are not just smart or connected, but we are specifically talking about representation of specific device or logical entity. Now, from an taking the definition from AWS developer documentation, and when we are talking about this, it could be anything from an application instance and not just only a physical device such as a thermostat or a dishwasher, but an actual application that's running somewhere, maybe on premises or on a cloud server, but also things like physical entities that are related to devices that connect to AWS IoT. So if we are thinking about this in the context of a car, as we mentioned earlier, this could be an engine inside of a car, which is a physical entity that's related to car. But that engine itself might not actually connect to AWS IoT. It might send information to the car, and the car would send the information up to AWS IoT. So now let's fill in a few more missing components on this larger diagram of how IoT things work. Now, specifically, I talked about those devices, but let's take a little bit of step back and start thinking about different sensors that might exist on those devices and inputs. Now, one of the first ones that might be things like thermometers that check different temperatures. We might also have sensors, motion sensors that determine whether there is some motion or not. There might be device inputs that come directly from some physical devices such as a button. There could be things like touch or other device inputs based on the environment. Now, another thing that I wanted to put here is the device states, such as locked or unlocked. And different devices might have actuators inside of them, which essentially allow you to do things which those devices might need to report on the state of the actuators that are present inside the devices. Now, these things could be like locks or levers or manufacturing equipment, and all of these might be things that might feed data into an environment or might require some input from outside of the environment to actually change and do stuff with. So let's go ahead and actually take another closer look at how these IoT things work. Specifically, let's look at the IoT devices and how sensor inputs might come into them. So inside of these devices, we might have a lock or a speedometer or maybe a control attached to manufacturing equipment. Now, each of these devices, different things would then connect to the device, and these devices would then need to have some communication protocol to actually send information around. And when we are talking about these communication protocols, we might be talking about things like Wi-Fi, but we could also be talking about other protocols like Bluetooth or 3G or 4G. And there's many others that might come into play because the communication protocols that we use with IoT can be substantially more varied than the ones we are using to just while we are using our electronic gadgets like laptops, for example. Those might all be tuned to Wi-Fi, the electronic gadgets, whereas the IoT devices might have other protocols for various situations that might come up to leverage those more effectively. So after these protocols get involved, the devices that need to connect to the internet eventually would probably do so, and then data would be sent over to a cloud provider. And the information that's generated up there or retrieved and is retrieved, and the information can be retrieved back by the device as well. There might also be information that's sent over to the internet to an on-premises environment. However, again, like the example mentioned earlier, it could be just that device is kept within the on-premises environment and never really sent out through the open internet. So now that we understand there's communication protocol layer in between, let us take a quick look at some different protocols that we might interact with. Now, this will be a really quick, so we don't have to dive too much in detail, but the language will be important and the terminology, which we will use throughout the course. So we might already be familiar with 2G or 3G protocols, which has a long range and takes a relatively high amount of power. There's also Wi-Fi, which we are also familiar with, which is relatively low power usage and medium range. But when we are trying to go for lower power usage and smaller range, we can go for Bluetooth options as a communication protocol used in IoT devices. And also we have near field communications or NFCs, which have a very small range and low power usage, because when we are using near field communications, we can also think of RFID, and these things are going to be activated by some other scanner or power that's actually being brought next to them. So that's why it's not actually using power until it's activated. So in addition to these transport protocols where we are transporting information, there are also data protocols that kind of fill fit underneath that. And taking a like brief view over these data protocols as well. So we will start with MQTT, which is a lightweight publish subscribe messaging model. Now, this will allow us to do things like see what different messages are coming from different channels and subscribe to those, and also send messages out to channels. So other devices and other people could subscribe to those bits of information for their applications. There is also WebSockets, which is going to enable bidirectional web communications. Now, this is going to allow you not only to send information from one point to another, but it is also going to allow to send information from that endpoint back to the original device and do that at the same time in an efficient manner. There is also HTTP, which we are very familiar with while working on web applications. And it's the traditional web application protocol that many of us are used to. Now, these are data protocols, but main reason I'm including these as well as the transport protocols is because There is a lot of variety when it comes to approach of protocols and in IoT. We are not just getting the exact same stack that we are using while developing web applications. There's a lot of differences that are happening underneath the hood. And here we have to take care how to maximize the efficiency of the IoT devices. So now we have a better understanding of the terminologies. Let's actually move on to the next section and start with the purpose of IoT things. So purpose of Internet of Things. Having a better understanding of the building blocks of Internet of Things. We must have a question like, why would actually IoT be used in organizations? Well, one of the first reasons we might do this is for data collection. Now we can think of an example of a truck that constantly sends GPS coordinates out to some home server and stores that data. Now we can eventually build a lot of value from the data that is collected. We can use this collected data to optimize truck routes or to do things that would enable us to save money in our own environment and potentially increase the amount of products that we can deliver and sell. There is also possibility of device interaction. Now, we can think of this with an example as a light bulb, which allows control over the color or brightness of the light bulb using some sort of application on the phone. Now, data collection and device interaction are two generic categories of what we might think encompasses the Internet of Things. But we can do both of these together. For example, we might have a thermostat that reads the temperature of the room and then allows remote changes to the heating and AC settings. And this would be both data collection by using the information of the thermostat for the room temperature, and then also device interaction by allowing some users, maybe with a mobile application, to change the heating level to a higher temperature. So now let us think a bit more about examining what kind of data we might encounter and actually collect. So in terms of the types, we have sensor data in text formats that might store from the sensors, giving us information. Now this could be JSON, JavaScript object notation, CSV, that is comma separated values, PSV, that is pipe separated values, or other delimited formats like those. Sensor data outputting media files can also just not be text-based formats, but also formats that are going to give us images or audio. We could also have video information coming out of IoT devices. Now, all these different pieces of data are going to allow us to do different things and eventually improve our applications. So, when it comes to improving our organization using IoT, we might see these split up into two general categories of revenue growth and operational efficiency. Now, there's the things that will probably fall somewhat in the middle, but this will help us get an overall idea with a few examples of how we might improve our organization. So the first might be improving customer relationships. Maybe whatever we are doing with IoT would allow us to have better relationship with customers in a way that would either generate more revenue or keep customers around longer So they continue to take advantage of our products, and we have an ongoing business relationship with them. We might also improve existing products using IoT. So maybe we develop a new feature on an existing product to improve the old feature. We could also create entirely new products and services with IoT and the options that it gives us. Now, all of these are in the revenue growth side, which would get us more money for organization. However, there's also the operational efficiency side, which would increase the efficiency of the organization or the product itself. Now, this could save money in the long term so that we don't have to do as much work or expend as much on particular tasks or resources. Now, also, under the operational efficiency side, we can make more informed business decisions based on the data we collect. For example, if we have a bunch of information coming in from a manufacturing side, we have all the information that is coming from the manufacturing equipment can be shared with a data analyst to look at all the information and help make important business decisions that will that inform that we are doing in the long run. Now these are just generic examples of revenue growth and operational efficiency. Later on, we'll take a closer look at some specific examples of how organizations have benefited using IoT. So now let's take a look at two specific examples of improvement to an organization that were directly the result of leveraging IoT. First, we will take the example of Centratech, and later on, we will go with the example of iRobot. Centratech works for the Australian government, primarily dealing with water shortages and other utility needs that local city councils and other parts of Australian government actually need in order to provide utilities to their residents. Now, Centratech previously has been doing manual repairs on many different fields. Now, those manual repairs were time consuming and expensive because they had to send technicians out to the device to repair them. They were also doing server management, so they had to pay their developers to develop not only to develop applications, but also to manage the underlying infrastructure that they were building those applications on top of. In addition to this, they were previously doing 6 hours training before every field deployment for the technicians whenever they had to go out for repair. Now, eventually, they ended up using AWS IoT to allow them to actually have the devices in the field be repaired remotely. That drastically cut down the amount of time and therefore the cost took to repair many of those devices. Additionally, they transitioned to the AWS IoT platform, which means they that because of using AWS IoT, they did not have to pay anybody for the management of infrastructure. AWS did it for them. Also, they had a simplified version of training for the applications. So, what happened was that the training time got reduced to 1 hour. So, these are just a few cases how Centratech actually improved by including AWS IoT in their operations. Now, in addition to this example, let us look at the example of iRobot. iRobot is a manufacturer of wireless and cordless vacuums that robotically go around the home and clean it up. Now, iRobot back in July 2015 sold 14,000 Roomba robotic vacuums just in a single day on Amazon Prime Day. Now, it eventually later launched internet connected Roombas, which are another version of its traditional robot vacuum machine. These internet connected Roombas needed to go out and actually use cloud services to leverage the additional resources that they developed inside of the cloud. Now, this required some authentication and authorization keys that enable that. But then they were also able to ingest real time data from robots that they had in people's home to the cloud. Now, this allowed them to continually improve on those robots and build features into them, leveraging the cloud connection that they had and the connection to the internet. Now, this is an example of improving product itself. So it falls in the spectrum of the other end that we talked about when it comes to organizational outcomes with revenue growth. These two examples of iRobot and Centratech are just a few of the examples that I've actually pulled from AWS website to take a look at how different people are using and leveraging IoT to improve their organizations. The Internet of Things has a bit of reputation for being insecure. Now, part of the reason for this is because that risks and responsibilities that are not understood by every organization before they start developing applications with IoT. So, I'm going to cover a few of the risks and responsibilities. One of the first risks that we see is that we might accidentally expose sensitive user data, and we need to be aware of that when we are working with IoT and take steps to mitigate any risks related to user data. We also need to keep in mind that there could be subject to different regulatory fines if we do expose user data or do things that we are not supposed to do with other bits of information or technologies that we are using. Furthermore, IoT devices themselves are often a pretty common target of attack. And for attackers trying to incorporate devices into their botnets, IoT can be very common attack targets. In addition to attack targets, we might also have to face ongoing legal changes or requirements when we are working with IoT. This is because IoT is such a fresh industry. There's many different countries and municipalities trying to figure out how to actually regulate and legislate changes around the Internet of Things. And because these are changing so frequently, you'll have to be aware of the continuous changes before developing our applications and devices. Now, in addition to these risks, there's also responsibilities when we are working with IoT. One of the first ones is medical privacy and compliances, and this kind of relates to potential regulatory fines. If we are working in medical industry, then we have to keep track of all the different laws that might regulate IoT devices. In addition to medical privacy compliance, legislation like HIPPA, there's also legislation like GDPR, which mandates data privacy and standards around data privacy. And this applies just as much to IoT as it does to any other application. Additionally, in some countries, we might be subject to different regulations that govern how different devices use various frequencies, and also how we use devices to collect information. All these might come into play depending on the levels of hardware manufacturing and different things that we are doing with these IoT devices. Also, we have to keep in mind that IoT breaches might result in some sort of reporting duty. So, if our company is doing something and maybe an accident happens and some data is breached, we may end up having to report that or bear some duty to let our customers know that they can take the appropriate actions. Now, we are going to talk about how we can mitigate a lot of these risks and really uphold these responsibilities later on, where it's important to keep in mind that these responsibilities exist so we do not end up like some of the companies that we will talk about now. Taking example of companies where there was a lack of attitude towards risk and responsibility was observed. So first we have CloudPets, and the second we will be talking about the Mirai botnet. Now let's start with the story of CloudPets. CloudPets sold internet connected teddy bears, and eventually what happened was that accidentally they left 800,000 user accounts credentials accessible. Now this was not necessarily something that was just related to IoT, but it represented kind of lack of security mindedness in the entire organization. In addition to these credentials they left accessible, they also left millions of recorded messages from these internet connected teddy bears accessible as well. Essentially, little clips of audio that people could spy on from the internet connected devices. And this was kind of next step in horrible things that could happen from being insecure with IoT. Now the result of this was that CloudPets is now defunctional and does not operate as a company. But in addition to all these things that happened, when CloudPets was found to be insecure, leaving those credentials accessible, hackers also discovered that the bears were hackable microphones. Essentially, you could go in and exploit the teddy bears to record audio and send it back to the hacking user. Now, this meant that CloudPets not only acted as a petty bad custodian of the data it stored, but it also didn't take time to properly secure the devices that were in people's homes. And this becomes a really critical example of how responsibilities were not met. Now, trying to avoid this, we'll go through the second example, that is the Mirai botnet. So, taking this as a story, once upon a time, there was Mirai and Dyn. Dyn was the DNS server provider, and Mirai was a virus. Now, Mirai virus spread to millions of IoT devices because it was designed to scan for open IoT devices and then try to access the device with a default username and password. This was kept in mind. This was actually figured. The strategy behind Mirai bot was that people usually do not change the manufactured settings, the default settings or the credentials. So many people did not configure their devices properly or change the default passwords and login credentials. Mirai was able to spread to many different IoT devices. And with those IoT devices, a hacker used them to actually attack Dyn. Now, Dyn was a DNS provider for large chunk of the internet. And because of this, when Dyn was attacked by millions of IoT devices, at the same time, users were not able to access popular websites that Dyn controlled for DNS. Websites like Twitter went down, and users were unable to actually access them from many locations. So the lack of security within the Internet of Things is not just a detrimental risk to the organization, it's also a much larger scale risk when hackers are trying to exploit by attacking the Internet infrastructure at large. So by this, I wanted to include some seriousness on the security threats that we have with IoT. In the future section, we will look into what are the techniques that we can use while deploying AWS IoT to mitigate the risks. So how does AWS fit in with IoT needs? AWS specifically fits in with our IoT needs. Now, first, let's ask the question, what does IoT require? When we think about this, we actually think only of the devices. But on top of these devices, we need some sort of device software. Now, this device software will allow us to interface with the devices that are generating the data. Now, in addition to the device software, we might need management services to help us doing things like secure those devices and also verify that the incoming information is from the specific devices itself, authenticate them, and integrate them in the workflows by monitoring them for security vulnerabilities and also for the basic functionalities, whether the functionality is executing as expected. Now, in addition to these management services, we also need to analyze the data and act on the data that is generated. So these are the categories that we'll be looking in the next section related to AWS services that enable all of these areas. So let us take a look at the specific IoT components. First, we have the device, and AWS isn't currently going to help us unless we are using a device that is provided by Amazon. For example, Alexa or Amazon Dot. Now, in addition to these devices, we need the software that we just talked about, and then we might also need certificates to verify these devices to some sort of authorization provider. So we know that these are the devices that are actually the part of the network. Now we need now in order to do that, we might need network connectivity to actually go in and connect to some authentication system. Now this authentication would then verify the certificates and then pass them on in terms of the information that they are sending to a public cloud, a local device, or an on-premises server. Now each of these different things might also have some certificate management system so that we can verify other local devices or just the ones that we are using now. Now, in addition to certificate management, we might need permissions that we know so that we know which devices are sending information to the public cloud or local devices as well. We don't want every device with all the permissions, or it might exploit those later on if it ever gets hacked. In addition to permissions, we want to make sure we can store some of the data that's coming in. So we need some data stores. We might also want to integrate the devices on the data that's coming in with other applications or third party APIs. In addition to that, we might need to keep backups of the data that is coming in or the devices that or the state of the devices. We might also want to monitor and log our devices to see if there's anything unusual happening, and also just to graph the variances in our device fleets. In addition, we might want to integrate into our system workflows so that if something happens on a device, we can trigger other things to happen down the line. Now, in addition to workflows, we we will also have lots and lots of IoT devices. So we also want to be able to create groups of these devices into logical categories. This is another feature that we might need while deploying a full scale IoT application. So this gives us a lot of idea about what are the kinds of things that would actually be needed to deploy a large scale IoT application effectively. So now let's take a look at how AWS starts to solve a few of these problems. Taking the first look at device software, AWS offers many different tools, and one of them is Amazon Free RTOS. This is an IoT based operating system. Now, it's going to be installed on IoT devices themselves to allow you to interface more effectively. This is an open source piece of software that we can integrate and allow to be used more effectively. In addition to this operating system that Amazon provides, that's very lightweight and it's meant to be installed on IoT devices, it also offers AWS IoT Device SDK. Now, this comes in multiple languages and provides SDKs for programming with IoT devices that need to interact with the AWS. Now, in addition to the AWS device SDK, which can be used on those devices, we also have AWS IoT Greengrass. Now, this allows to extend AWS services down into your own device. So rather than having all your devices need to connect up into the cloud, we can extend the functionality of AWS services down into our own hardware, or perhaps in our own manufacturing environment, or the location where we need some sort of AWS services functionality, but the device doesn't always get connected to the internet. So integration of AWS IoT expands the possibilities that we have with devices. In addition to device software, we have AWS management services. These are not specific to IoT, but they are all useful for IoT itself. One of the first ones in the thing is the thing registry. This allows us to register all the IoT things that you can have so that you can keep track of them, use certificates for them, and do bunch of other things like grouping them and adding metadata. In addition to the thing registry, and identity also features security and identity verification. Now these are going to allow you to assign certificates to different things in the registry create certificates that you might need, and otherwise control permissions and things along those certificates and authentications. There's also AWS IoT Device Defender. This helps us by auditing the fleets of IoT devices and making sure that we are configuring them with best practices and otherwise notifying if we are not. Now, in addition to Device Defender, we have Message Broker, which will allow us to send and receive messages from IoT devices effectively and then take action of those messages down the line. We'll also be talking about IoT Thing Graph, which will allow us to keep track of the various IoT things underneath our organization's umbrella. And finally, we have identity and access management, which is less related specifically to IoT, but more to AWS in general, which is identity and access management. We can essentially think of this as the overlying system that is helping keep sec- sec- keep secure and properly authenticated while working with AWS. It manages everything from granting user permission to do things on AWS services to also making sure that any application that we are running inside of the AWS cloud have permissions appropriately to act on other services. So in addition to the management services, the final kind of building block here is the analysis and action section. And AWS has many different services to help us in this, ranging from AWS IoT analytics to help analyze the data that's coming in from the fleet of IoT devices and then developing insights from it. Also, AWS SiteWise, which is going to help manufacturing environments actually keep track of equipments that's on their location. There's also AWS IoT events, which help us to act on different IoT things that are coming from IoT environment and the trigger to create initiate the trigger reactions for particular events. Finally, we have other AWS integrations even outside of these specific services. We can integrate with a vast variety of AWS services that are already present in the AWS ecosystem. So now we have an understanding of the various services. In the later section, we will dive into each of these specific services and talk about how they integrate with AWS IoT. So now, comparing AWS IoT to self-managed IoT. Let us compare these services as there are some advantages of AWS IoT to self-managed IoT. Now, first off, I want to just repeat that IoT is complex. There's a lot of different parts that are moving around that we need to actually have to create a secure and useful IoT system for our application. And AWS is going to allow us to actually simplify a lot of this by taking these responsibilities on themselves and allowing us to leverage their services without having to do it all ourselves. Now, all these grayed out services are examples of things that AWS can actually help us with. While we go ahead and take a look at how AWS does this, one of the let us start with AWS IoT, with the feature that AWS IoT is serverless. So what do we mean by serverless platform? So a quick understanding over here, it can be an infrastructure. Serverless is is having infrastructure that is managed for you. You can have infrastructure that scales with the requirements that you have, and you are only going to pay for what you're using. Additionally, we can focus on application code and developing products rather than having to manage your infrastructure. Also, the code that we are writing can be triggered by different events. And this is advantageous over continuous 24/7 execution of the code at even idle times. Instead, we are paying for the code for only the duration of time when it is actually being executed by being triggered due to an event. Example of non-serverless architecture would be having to manage your own hardware and operating systems. Maybe you'll also have to over provision capacity when the resources run out. Further, we might also have to spend time focused on managing infrastructure rather than actually writing application code. Maybe we also have applications that are always waiting to be used, and we are getting some waste from that. For these examples, we see from these points, we see that serverless computing is actually very beneficial. So trying to use AWS IoT is advantageous over non-serverless architecture. So taking a look at why is serverless important for IoT. One of the first reasons is that there has been a rapid expansion of IoT. There are expected to be about 75 billion IoT devices by 2025. This means that we are going to have a lot of important work trying to keep up with the applications that are able to scale with the amount of expansion. Additionally, there's a lot of quick iteration that's expected within the IoT and IoT developments. The harder the harder to do that if we have to manage our own infrastructure. Having that infrastructure being managed by AWS is going to allow to develop more quickly on top of that. Additionally, we are also going to want to reduce the overhead that we are using when developing these applications and rapidly scaling to try and meet the demand, whatever IoT devices. So this is going to allow us to actually save money and pay as we use and not spend tons and tons on infrastructure and provisioning of our own hardware, such as our own servers along these lines. So outside of being serverless, AWS IoT offers other services related to security. Now, we mentioned a few of these earlier relating to authentication, permissions, to managing certificates, and to monitoring and logging. But I want to point out that trying to do these on our own in an environment, perhaps on premises or in other locations, would become a significant burden. In AWS, you get all these out of the box and integrated directly with your IoT application. Now, because of this and because of other services, AWS allows you to have resilience in your application when integrating with other things. In relation to resilience, the hardware management that AWS offers, similar to the serverless, essentially, one, we don't need to pay for hardware, and secondly, we don't have to fix it ourselves in case it does break. So, in case of a disaster or catastrophe, rather than having to deal with all that on our own, we can have AWS there to help repair our things. Now, we might have to deal with the bugs in our application ourselves, but the underlying hardware layers will actually be taken care by AWS. For example, when being handled by AWS effectively, it gives us option to distribute our application across AWS regions or availability zones so that we don't have to worry about one particular data center going down and running everything, ruining everything when you are doing. Now, in addition to this, there are other AWS services managed for you. There are a lot of other AWS services. So we can include these things, for example, cloud backups, stream data processing, and many other kinds of workloads. And these are going to be only flexible with what we want to build on AWS and also adjust more quickly and effectively by leveraging these integrations. Now, finally, we can point out that AWS services are usually going to scale up with our needs. Now, because of this, those serverless services are going to be provisioned. We'll just pay what we need, and our application will be scaled up based on the requirement. So, going for a quick summary of what all points we have discussed, we looked at what is IoT. We looked at some basic IoT terminology, and we looked at the purpose of IoT and how we can leverage Internet of Things effectively in our organization. We also looked at risks and responsibilities that we have while developing IoT applications that we need to make sure we are not ignoring. Another portion that we talked about is how does AWS fit in with our IoT needs? Specifically, how the device software could do things for us, what we need to run device software on IoT devices, the management services, things like authentication, certificate management, and managing devices and things themselves, and also how we can analyze and enrich some of the data that we have coming into IoT using some of the AWS services. Moving ahead into specific areas, we'll take a quick highlight of the AWS IoT services. So now getting started with AWS IoT, let's take an overview of what all topics we'll be discussing over here in this section. So firstly, we'll go through the device software. We'll be looking at Amazon Free RTOS, Amazon AWS IoT Greengrass, and AWS IoT Device SDK. These will allow us to understand the software that runs on IoT devices and when we are interacting with AWS IoT. Now, for the management services, we will look at some management services specifically like Device Gateway, which helps us to manage connections into AWS IoT and out of it. We will also look at authentication and authorization. AWS IoT handles both these processes, and we will look at thing registry where we can register our different IoT things. Further, we have fleet indexing service from AWS IoT to allow us to take some of the information about things and effectively index it through when we need to do tasks like finding various devices. We'll also look at job service after we have already spent applications. Maybe we want to update them after we have already deployed applications for updating and making different changes to the devices. We use job services, device defender, which helps us in auditing and securing the devices from attack or potential misconfigurations that we may accidentally leave. Now, addition to that, we will go through AWS IoT jargon to kind of understand the broader picture around a few of the terms that get thrown in AWS IoT to understand the terminologies better. So, moving ahead with device software, and the first one is Amazon Free RTOS. Amazon Free RTOS is an operating system for microcontrollers that makes small, low power edge devices easy to program and deploy, secure, connect, and manage. Now, this comes directly from AWS documentation. But what is so special, and why do microcontrollers need an entirely separate operating system? So, let us have a look at a few facts. In 2018, there were 23 billion IoT devices in operation. In 2018, there were 30.5 billion microcontrollers sold. Over in 2022, it is forecasted that there will be 43.7 billion microcontrollers sold. And in 2025, there will be 75 billion IoT devices in operation. So these microcontrollers are growing along exponential lines. Now, let us look at a few challenges that we have with microcontrollers. So microcontrollers have special requirements of operating system. One of the first reasons is that the limited amount of storage space. Now, this means that there's smaller amount of actual capacity on microcontrollers to store things like files or programs that they run. In addition to that, there's a smaller amount of memory, not just hard drive spaces. We can also think of the RAM that is actually being used while running different programs. So it doesn't have much of available memory. Finally, there is also limited functionality, and it can be hard to program effectively with the restraints that are placed by the storage space and memory because we don't get the same tools, libraries, and others system environments. So, what is the relationship between Amazon Free RTOS and microcontrollers? First, it's a leading real time operating system for microcontrollers that was acquired by Amazon. It fulfills the need for operating system of tiny devices wherein operating systems like Android, Linux, or Windows cannot fit in. It was specifically designed for microcontrollers that have limited memory within the range and potentially the storage space as well. Now it only fits in these needs, but it went ahead and actually did things like create a free RTOS ecosystem or community that had support, libraries, and carefully managed intellectual property and licensing so that many different organizations and companies are able to make effective use of this. Furthermore, Amazon Free RTOS has connectivity libraries that allow us to connect to things like Wi Fi, Ethernet, and Bluetooth Low Energy. Additionally, it has added functionality that supports things like MQTT messages, adds additional security features, and allows for updates of software on Amazon Free RTOS, as well as effectively integrating with other local devices. So now let's go ahead and visualize the Amazon Free RTOS and see how it works inside a real world scenario. We might start with a microcontroller that has Amazon Free RTOS installed. Now it's going to be able to take advantage of libraries like connectivity libraries for Bluetooth, low energy, or Wi-Fi, and that it might also connect to a router using Wi-Fi. We can also take advantage of other libraries on the Amazon Free RTOS device, like the Device Defender library, which could ship bits of information over to the AWS cloud. Now, that might actually integrate with the Device Defender in the AWS cloud and allow to monitor microcontroller devices more effectively. But there's a lot of other things in here too. There are libraries for initiating shadows that talk more about, and we will talk more about it in the later section. Shadows enable Shadows are basically JSON files that enable uh, the status of the device. It is a service provided by AWS IoT, and we will look into it further. We can also use MQTT libraries and connectivity libraries to send updates over AWS Cloud Message Broker, or even do things like over the air updates that would allow us to interact with AWS services to update the software on the microcontroller with Amazon Free RTOS. In addition to these, we have few libraries that are included that are also things with Amazon Free RTOS. So Amazon Free RTOS provides the benefit of all these libraries, and we'll have to build this functionality ourselves if we do not integrate with this. And furthermore, it provides integration with AWS Cloud. So looking at the benefits of free RTOS, first, it easily enables connectivity to Amazon Greengrass or IoT Core, which we will discuss just in the next section. IoT Core is essentially the functionality inside the AWS cloud that integrates with IoT devices. It allows us to perform increased security using TLS support, key management, and encryption. It also does things like key management, so allowing to create and store keys in a safe way and deal with encryption messages and create encryption while we are sending messages for communication. It also enables multi-threading on the local devices. Now, what this basically means is that we can have some management tasks that are automated by Amazon FreeRTOS itself to free up developer time so that they can focus on actual important functionality that they are writing for their application and not have to deal with many of these overhead management tasks. So hopefully this gives us a level of understanding for AWS free RTOS, some of the features and benefits that we receive from it. So let's go ahead and look at the over the air updates. Now, a microcontroller that is running Amazon free RTOS, we might have a piece of software running that suddenly has security vulnerability introduced to it. Now, when this happens, we might actually write a patch for the vulnerability and want to apply it to the existing software. So, what we do is that we would write an image of the software and upload that to the AWS cloud. Once that is done, we actually are able to send it through over to the microcontroller with Amazon free RTOS and essentially schedule an update for that to replace the existing software. Now, once the process has been scheduled, it will notify something on the device called the OTA agent or the over the air agent that will download the new firmware, which is the software patch to the device. But it's going to do this piece by piece by using MQTT so that it can assemble everything and then verify that it is the software that is expected. Now, importantly, doing the signature verification, which essentially means it's going to check to make sure that this software is legitimate software and not just a malicious code that some hacker is throwing onto this device and hoping to get updated. After the software has been verified, the device is actually going to have over the air agent to go ahead and check that it's the latest version. And it's also going to run a series of tests to make sure that the application with the new image doesn't have any conflicts or errors that arise in comparison to the old version. Now, when all those tests are passed, the old version of the software is actually deleted and we go ahead with the new software that via the new image that is loaded on the device. Now, the final part is that this will eventually be reflected inside the AWS cloud so that this happened on your device that requires an update and we can manage and monitor that later on. So let's go ahead with what device support Amazon free RTOS. There are a lot of microcontrollers that are listed as AWS partner vendors, such as Espressive, Nordic Semiconductors, and ST Microelectronics. These all microcontrollers are produced, are the hardware platforms that are designed and have passed tests to be able to integrate with Amazon FreeRTOS, the operating system. Now, this is same for Amazon Greengrass software, which we'll talk about in the next section. But there need not be a necessity to have a partner, AWS partner vendor, to use the Amazon free RTOS, AWS free RTOS. We can use our own hardware. But how do we do that? So that is where AWS IoT device tester comes into the picture. It is a Windows, Linux, and Mac test automation tool for connected devices that can determine if your device running AWS IoT Greengrass or Amazon free RTOS is authenticated and can support. So essentially, this will allow us to test if your own hardware is going to be effective device for Amazon free RTOS or Amazon's IoT Greengrass. Going ahead, let's take a look at how this works. So the first step is that a machine running the device testing software. Now this would be a Mac, Linux, or Windows device that downloads and installs the device tester software. Now after this, we'll also need to have the device to be tested, which will be a potentially compatible device that is eventually plugged in to the testing. And a series of tests are then run. Now these run in sequence because a microcontroller cannot run every single test at the same time because of the potential limitations on the storage space of the devices. So several tests will be sent over. The results will be sent back and the process will continue until a full suite of tests have been run on the device. Now, if after all the tests, they all return successful, this means that the device is effectively ready to go and can be used with AWS free RTOS. Going ahead with device software, AWS IoT Greengrass. IoT Greengrass extends AWS to edge devices so they can act locally on the data they generate while still using the cloud management, analytics, and durable storage. Now we have discussed edge devices before. So let's go ahead and take a look at what exactly edge devices are. Edge devices have full operating systems. In contrast to microcontrollers and Amazon free RTOS, they are actually things that run something like Linux, Android, or iOS. They also differ in terms of their hardware. They usually have more memory and storage than microcontrollers and allow them to run these operating systems. Further, they will have IoT connections, so they are going to be able to interact with IoT devices and the AWS IoT core. So not just one or the other, but both. So why might we use edge devices? One of the first reasons is because of latency. We are always going to be bound by the speed of light. Information itself cannot be transmitted faster than that, and therefore we will have some latency when we are trying to interact with different locations that are far away from each other. And sometimes, when these Internet of Things devices are relatively far away, they are going to have to deal with, with latency and intermittent connections. Could you please provide me just 1 minute? Um,
Yes, you can.
Actually, my laptop battery is running low. I'll just plug in the charger.
Okay, fine.
Okay, so moving ahead. So the first problem that we saw was the latency, and that is why we need to use edge devices. Secondly, yeah, so one point that I missed here actually is that in case of critical situations, like taking an example of a few situations that surround self-driving cars. So we don't want to have to go and make a connection to the cloud in order to determine whether or not we should stop suddenly to avoid hitting a pedestrian. So these are the places where we realize that edge devices are actually useful. So we get input from different sensors and processes, and the computation is performed locally on site, and decisions are made based on the information. The decision data can eventually or later on be sent to the cloud to actually improve the algorithms that are running the self-driving car. Now, those are just a few examples, but another big reason is because of economics. It's expensive to store worthless data, and the volume of data created by IoT is massive. With the billions and billions of devices that are continually being added to the IoT landscape, creating and storing all this data is very expensive. And it's being created at a faster rate than the reduction in price for storage is going down. So essentially, this means that eventually it's going to be very expensive if we store all the information, all the data that is generated in IoT devices and are not filtering and throwing away the irrelevant data. Now, finally, we might also use edge devices because of regulations. These are frequently becoming more regulations surrounding Internet of Things, and restrictions on moving and storing data already exist. Thinking of things like GDPR and other policies along those lines. So we are going to need some flexibility when it comes on how to interact and deal with IoT data. So now hopefully we are convinced why AWS IoT Greengrass is a good option. So the next step, we will go and look at AWS IoT Greengrass core. So this is the actual software that runs Linux systems, and it takes at least 128 plus MB memory as well as 1 gigahertz of processing power. So what exactly does AWS IoT Greengrass Core offer? So here we see going ahead the main features and components of Greengrass. So taking it in context of other IoT devices, now we might have many different IoT devices and a bunch of different settings. But we are going to use Greengrass. We'll have a Greengrass core. Now that will actually be another device which will run Greengrass core software. Now inside of that device, one thing that we are going to use is Lambda runtime to actually process bits of information coming from IoT devices. So any events that they emit might get sent over to the Greengrass core, and those events can be processed and acted upon. We could also use the Lambda runtime to send pieces of information into the AWS cloud and interact with other IoT core services like the message broker. Now, with the Lambda runtime, we'll write response to the events that IoT devices emit. Now, with that, we'll need to update the code that we are writing in. So we'll also be able to integrate the Lambda functions of AWS cloud and perform over the air updates for the IoT devices. Whenever we have a new function with new bits of code that we write, we can send over the air updates, and the Lambda function in AWS Greengrass core will replace the existing function so that it can take decision and actions depending on the needs, and it can patch it appropriately to make more efficient and other things along the lines. So what are some characteristics and how do they compare to the cloud-based Lambda function that AWS offers? There are two distinct categories that we should be sure to keep apart. So cloud-based Lambda functions are cloud-based serverless computing. Also, the code that we write in the AWS cloud will run in response to the configurable events. We can also update the code using Lambda functions with the AWS CLIs, SDKs, and the console. And in the cloud Lambda functions, we see that we can write functions in Node.js, Java, C Sharp, Go, Python, and many other languages now supported by Lambda layers. And finally, we'll have access to do aliasing, integrations, and versioning. All these comes with cloud-based Lambda functions. When we are working with Greengrass Lambda function, on the other hand, those will be for edge device based local computing as opposed to cloud-based computing. We'll be able to take action on local device events without a cloud connection. So it won't be necessary to initiate a connection with the cloud before initiating the trigger for the events. And the events that are running on the Greengrass core itself. Instead of updating the code inside the console in the cloud, we'll be able to configure and schedule Lambda updates over the air with green grass. We can also write functions in a smaller set of languages, which is Python, Node.js, Java, and C. And lastly, fail-safe reverts to the previous version. That is, when we decide to push an update, we can revert or roll back the update and go back to the previous reasons if for some reason the update is not working as expected. Finally, we can track the update and the progress inside of the AWS console with Greengrass. So essentially keeping track of not the functions inside the Greengrass course are updated successfully. Now going ahead with the security provided by Greengrass. In relation to security, we have features that Greengrass provides over security levels. The first is TLS, mutual authentication. Now this allows to securely encrypt traffic between Greengrass core devices and the AWS cloud. We're also going to get access to local Lambda authentication. Now, these local Lambda functions use SIGV4, which is a method for authenticating actions to AWS services. Now that will essentially create Lambda functions to take action on AWS cloud services. In addition to this, we will be able to leverage Greengrass Secrets Manager, which will move secrets from the cloud to the edge on your Greengrass core devices and enforce the same policies that the cloud was enforcing. So essentially, we make sure that particular devices have access to only the secrets they are supposed to see. And we can do the exact same thing with any policies and keys we provide to the Greengrass Secrets Manager. Now, outside of the Greengrass Secrets Manager, we have the ability to use hardware security integration. Now, this is for the device that have a secure element, which is related to the public key cryptography standards or PKCS that improves security where data is stored in physically on the device in a particular security module. So this means that we have advanced level of security with our Greengrass core devices and their physical capabilities as well. But in addition to the security also comes the functionality when it comes to Greengrass connectors. So here we see some Greengrass core software running on it. We might have bunch of IoT devices that are still generating that data, and it could be piling up on our Greengrass core. Now, some now we might want to do something with this data, perhaps send it to the AWS cloud. And fortunately for us, AWS provides these connections, and we will make creating applications that integrate with things like Amazon Kinesis much easier. Now, these are provided for a variety of different applications, including Kinesis, CloudWatch logs, and Device Defender, and many others like Splunk and third party vendors that aren't even related to AWS. So effectively speeds up the process of developing applications on Greengrass core devices. Now, in addition to speeding up the development of application with connectors, we also have the ability to take advantage of AWS's machine learning capabilities when we are working with Greengrass. So to start off, Greengrass core one more time, and those IoT devices that are generating bits of data. Now, in this particular use case, we might want to be able to analyze this data in real time and determine if there are any anomalies. But in order to do that, we would probably want to create a machine learning model. Now, we could do this by working with Amazon SageMaker, another service related to Greengrass, and we could use that to generate an algorithm using a lot of compute power in the cloud, something that would not be possible to do on IoT devices or the AWS Greengrass core. Once the model is computed and the machine learning model is out, that itself could be deployed to the Greengrass core along with any software that's required to run the different models that we might create. Now, from that, we could actually output live data and detect any anomalies that are happening within our data. And then eventually, if we wanted to act and, and send back the data to the cloud, the information, or simply act on it locally by using the Greengrass core as well. So now we have seen the advantages of Greengrass core. Moving ahead, we will go to device software, that is AWS IoT device SDK. Now, this is a very important piece of service that is provided by AWS IoT. Taking a quick look at this, AWS device SDKs allow us to easily connect to AWS IoT and other AWS services. They are going to use MQTT or MQTT over the WebSocket protocol in order to make those connections. And they are also going to publish and allow you to subscribe to IoT topics and interact with rules and shadows. This is a subset of the functionality, but this is what essentially is offered by the device SDK, which is a massive library of tools. And using this library, we can leverage all the functionality of AWS IoT. Now, moving ahead, AWS IoT device SDK comes in different types. It will provide support for things like development in iOS and Android. It will also allow for development using Python or embedded C, C++, Java, and JavaScript. So essentially, a lot of different support for many different platforms and languages to do whatever you'd like to do on your AWS. This will save your time in working while manually coding and interacting with the APIs calls to AWS services and allows us to take advantage of security benefits, new features continue to be added and more functionality. So this is a very useful service provided by AWS IoT. So going ahead, we have management services. So whenever we are interacting with AWS IoT, connections to the AWS services are going to be handled by the device gateway. So let's go ahead and take a look at what exactly the device gateway is. The device gateway is a fully managed auto-scaled entry point for IoT devices connecting to AWS. So here in the diagram, we see that we have a situation with an IoT device that is trying to connect over MQTT or WebSocket and is going and sending information through to AWS IoT. That information will go through the auto-scaled managed device gateway. Now that information is routed to the message broker or the shadow service or maybe the device defender. And any of those different services are going to rely on the device gateway to route the traffic all the way back. But now what happens in case we have a bunch of more devices? Let's say we have 1 million devices that get added and we have a lot more traffic that's coming through. The nice part about device gateway is that it will auto scale. This means that we have one device to 1 billion devices. The device gateway will handle all of that increased throughput for us, and we won't have to do a thing. We just have to pay for more for the amount of traffic, for the amount of time it exists. However, AWS IoT will handle the scaling of infrastructure in the background that we need to actually process this increased throughput. So device gateway is an ever expanding door for whatever traffic requirements we might have that is completely handled by AWS. Going ahead with authentication and authorization. So let's take a brief look at what authentication and authorization are. When we are talking about authentication, we mean being able to prove how we are. We are talking about authorization, we mean being able to prove what we have permissions to do. Now, by we mean IoT devices that might take advantage of these two different concepts. So let's first start by looking at AWS IoT authentication. There are multiple forms of authentication, and there's going to be different purposes of that authentication. So the first form is X.509 certificates. These are also identity and access management users, groups, and roles. And we'll talk about that in a moment. Another concept inside the AWS is umbrella. After that, there's Amazon Cognito identities, which again are another concept related to AWS. Then we have federated identities, which allow organizations that already have existing federation and identity solution to integrate with the IoT. And finally, there is also custom strategies that we can use while working with IoT. So what are the purposes of each of these forms of authentication? Well, X509 certificates are used on IoT devices so that those devices can prove they are the device that they say they are. Now, the IAM users, groups, and the roles are going to allow things like the CLI, the SDKs, or you could integrate them in webs and desktop applications that might be some components in AWS cloud. With Amazon Cognito identities, these will be tied to mobile applications and mobile devices that use the mobile application, and the federated identities will also be used sometimes for web and desktop application. With custom authentication strategies, it could be for all, like web, desktop, mobile applications. In addition to authentication methods, how we can deal with authorization in IoT. There are two kinds of authorization that we might interact with. The first is AWS IoT policies, and the second is AWS IAM policies or identities. So what do these two different kind of policies actually allow us to do? So let's take a look at the authorized section that we might get from having one of these policies. One of the first action we can take with an IoT policy would be to publish or subscribe. Now, this would mean that we could send or receive messages to MQTT message topics. We could also do things like manage actions inside of the AWS, where we might use an IAM policy to do things like manage certificates, IoT things themselves, rules create rules related to those IoT things, or other actions of that nature. Now we could also use AWS integrations. For examples, we have an IAM policy set up to allow us to interact with other AWS services. Now this could be things from storing data inside of, of Amazon S3, or maybe integrating with the databases like DynamoDB. Taking an example of many of the kind of actions and the layering that and complexity of these policies we could get into. So let's take a look at how authorization and authentication are tied together. Specifically, what could we attach as an AWS IoT policy versus AWS IAM policy. So when we are working with AWS IoT policies, we are working we are more likely to get accesses to those of Amazon Cognito identities or X509 certificates. While working with IAM policies, we associate with users or with groups or with roles. So both of these are kind of different kind of policies with not only different permissions to take actions on IoT related concepts or AWS related services, but they are also frequently being attached to separate things, like we can see here in the diagram. Moving ahead to Thing Registry, which is a critical component of AWS IoT. So when we are working with AWS IoT, we might have a lot of different devices of same type, and we might have a lot of various different devices of completely different types. Now, when we are going to want a way that we can allow all of them to connect to AWS IoT, and we want all of them to be secure connections to prevent from getting hacked, then we also want all of them to send the data across varying devices into our AWS IoT system, so that can be processed and evaluated by other applications. So we do all this by using thing registry. With thing registry, we are going to be able to bunch a lot of different devices and classify them into things called thing types. Now, thing type in this example might be a car, where we have an electric car, a sports vehicle, or just an average automotive car. So here we see that the similar attributes we could actually have in each of the types of cars, which are searchable attributes of the thing registry. So going ahead with the sports car and all of other cars, we might have the horsepower of the cars and the year that it was actually made and the price of the car. Now these all are searchable attributes for every single kind of car that we are using in our thing. Now, in addition, we have searchable attributes which are a list of now along with the searchable attributes, we have a list of non-searchable attributes that are essentially just metadata about the car that we cannot use, the searchable attributes. So we are using information wherever we are looking at IoT things. So moving ahead with things type, we can have things that have 3 searchable attributes and up to 50 non-searchable attributes. Things can only be associated with one thing type, and there is no limit to the number of things types that we can have. So these are the conditions that are set by AWS. Over the attributes, we see that we have key value pairs, and the searchable attributes, which help us find specific things. So if we want to find the cars with horsepower above a specific number, or maybe cars that only have a make of 2017 or 2019, this would allow us to do that. Additionally, we also have non-searchable attributes that simply provide extra metadata. Now this becomes useful if we have maybe some cars, seat warmers or without seat warmers. We might want to integrate okay. So moving ahead with this, ma'am.
Yes, Anmay?
Yes, ma'am. So actually, I saw your message. I have like a couple of slides that are left actually, but
Okay.
there is one more thing that I have the demo that was scheduled. So
Okay.
if if it is convenient for
How long
you,
it will take, Anmay?
ma'am, the slides are actually uh, like 20 more slides are there. But
Demos, then shall we
yeah,
go to the demo and we'll conclude it?
yes, ma'am. Okay, sure. So
Thank you.
I'll share my screen. So what we are going to see in the demo is that we'll be creating an AWS IoT setup wherein we will be registering an IoT device in the AWS, and we will see step by step like what is the process for registering an IoT device. So okay, I'm logging into my AWS account quickly. Okay, so ma'am, are you able to see my screen?
Yes, Anmay, we could see.
Yeah.
Thank
Okay. Okay. So so this is the AWS management console. That is the login page. You can create your AWS account and like it's free for some starting period. I don't remember like how much what is the duration for the free usage, but um so over here we will like type IoT, and here we see IoT core. So we will click on IoT core. So this is the AWS IoT core where we find all the range of IoT services provided by AWS. So this is the page that we see over here. When we have to create an IoT device or IoT thing on AWS, the first thing that we do is we create a policy. So we go in the secure tab, and over there we click on policies. So I had already created a policy while setting up the demo. So we can click here and create a policy. It can be any name. So so let's go ahead with plant plant moisture. So the demo what we are going to see is actually there we will see this in two steps. The first thing is we will create the IoT device on AWS, and then we are going to use the test feature that is available over here to actually publish and subscribe messages to the IoT device and get a response back to the AWS console. And the second step would be that we will be getting the data from another device itself. So in the laptop itself, I will create this from using Python code, Python script. I will be sending data to the AWS device that we have created, and we will also receive a response based on that. Okay. So I'm creating the policy which is called plant moisture, and in the action I'll have to type IoT. There's usually a drop down menu that is provided here, but it's not coming up right now. I don't know why. All right. And over the resource ARN, we put a star. So these are the 3 steps that we have to take care of. And in the effect, we'll create a click allow and go ahead and create this. So we see this message success, that a policy has been created successfully. So this was the old policy that I had, and this is the new one, plant moisture. So clicking on this one. So now when the policy is created, we will go to this tab that is manage, and we'll go in things. So this is where IoT device is called a thing in AWS IoT. So over here also I have one thing created, one device created. Um, I'll go over and create another device. So I'll click, I have clicked on created in the last tab, and now I'm going to click register a single AWS IoT thing, create a single thing. So we have to give this a name. So we can give this name my Raspberry Pi or my RPi 2, because I have one that is already created. And we don't need to configure any other settings over here. So we can just scroll down and click on the next. Now, when we come to this section, we come to the place where we have to generate the certificates that I was talking about in the presentation. So these certificates actually help us in authenticating that our device is actually connecting to the AWS account and validating basically the account. So we go on we go and click on the create certificate. So success uh, certificates are created successfully. Now, when one thing has to be noted, that when you do it for the first time, when you create a certificate for the first time, it will show an error. It will take some time, actually, a couple of minutes, and it does some background process, and then like it's a one-time process actually. So mine was done some days back, and now it is done successfully. So here we get 4 certificates. As you can see here, one is the a certificate file, one is a public key, a private key, and there is a root CA for AWS. So these are 4 things that we have to download and keep in a local local directory. So I'll click on download on all 3 of these. And for the 4th one, we will notice that it takes us actually to a different page, which is a documentation page of AWS. So that is not, the 4th one is actually not a unique certificate. It's a common certificate over here. So we will go and click on this AWS root CA1. So what happened was that, all right. Yeah, so this was the page where we had the 4 files. The 3 of them, I downloaded it. And the 4th one actually opened this documentation page. And going in the documentation page, I clicked on AWS root CA1. And this is this file. So the 3 files I downloaded, I'll just open it and put it in a folder. Mm, So I'm placing these 3 downloaded files in demo2 folder. And this second file is something that I'll copy completely that we had opened, copy, and we will paste it in a notepad or text file. Mm, Creating a name. Yeah. So this is the whole file, and we have to name the file. Uh, yeah. So this file has to be named as this itself. So I'll copy this Amazon root CA1, and I'll rename this. Okay. So now I have 4 certificates available with me. Going back to the page where I had got these 4 certificates. Now uh, I'll click on activate. So it says successfully created thing. That is, one IoT device is successfully created on AWS IoT. And now we'll go to attach a policy. So this is what we did initially. That is the first step. Before creating a thing, we have to create a policy. So the policy that we have made right now. So I'll attach, clicking on that button. So here I see that I have 2 policies available. This is the new one that I created, plant moisture. So I'll go ahead with this, or perhaps I can go ahead with the first one also. That is not a problem. Okay, we can attach multiple policies here. Yeah. So, okay. So where are we right now? We are in the AWS IoT things tab. So we see that I have 2 things registered over here, name and the type. Um, so this means that there are 2 IoT devices that are created on my AWS IoT system. So this is the second one, my RPi2, that we have created right now. So over here, we see the details. And in this, we will go to specifically interact. So what do we see in interact is that um, this is actually an address which is used while interacting with this device. When we will use this one actually in our Python script that we will use to connect with this IoT device. Over here, we see MQTT, and you can click on this learn more option. So device shadow MQTT topics. So just let me go back to the tab. Yeah. So over here, we were in the things tab of AWS IoT, and here we had created this IoT device, my RPi2, and over here we go in the interact tab, and from there I clicked on the MQTT, and this is learn more, and this is what opened this tab. So what I want to highlight here is that these are actually few topics, MQTT topics. So this is the terminology specific to AWS, but it is nothing but how we publish and subscribe with our IoT device to communicate with the IoT device. So here we see get accepted, update, update accepted. So this is the format actually, like a dollar AWS slash things, which is like standard for all the things. Then thing name. So what is the name of our thing? We created the thing called my RPi2. So that name will be here slash shadow. So this is a code that we will use. And this code is called shadow topic prefix. And going down, we click, like, let us say if we go down and click on get or get accepted anyone. So here we see what is the syntax of get accepted. It is shadow topic prefix slash get slash accepted. So for any of the topics that we see here, this is the first part, shadow topic prefix, and that was what I was showing here. It is this standard. So what I will do is I'll copy this one and take it to the same folder that I had and create a file over here. Interact. And over here, I'll just paste AWS thing name shadow. What is the thing name? Will replace it. So it is my RPy2. Okay. And then we have these get over here. What you see like /get accepted /update accepted. So these are a couple of MQTT topics that are used to communicate with IoT device. Okay, so going here, I'll like type get. So I'm creating just 4 statements which I'll be using right now. Update accepted. Okay, so what you are seeing here is just that shadow topic prefix that I have over here. And after that, I have just concatenated this like express this line with the topic. All right, with the thing name changed. So these are the 4 things that I have taken down. Okay, now going back to my AWS IoT thing. My browser is taking some time. Yeah. So now we'll just simulate a connection with the IoT device. So how do we test the connection? Um, we go over here, which is in the AWS IoT, the option test. So going in the test, what we see here is that we can subscribe to a topic and publish to a topic. Okay. So let me just copy this message that is update. I'll copy this string and I'll paste it here and I'll subscribe to the topic. So what we see here is that like communication has been initiated, and this is actually the update statement. So in the update statement, we can send some sort of JSON format over here. So I have a pre-created JSON format from the last demo that I had done to set this new one up. So this is a file. This is a small string, we can say. So I'll replace it over here. So what we see over here is that first of all, I just put this string, which was AWS/things/my device name, which is my RPy2 shadow. This is standard. This much is standard. And then the last update is actually an MQTT topic. So I copied this whole text and put it here. Then I published it. So I got this console. Over here, I'm sending this update to my device. What is this update? So it has the state, which is having 2 values. One is desired and one is reported. So it says that state dot reported dot moisture is low. So right now I'm telling my device that the reported moisture is low. All right. So okay, just going ahead with this. Yeah, so what we see over here is that this value has with the current timestamp, the value has been updated to the device and the device is now set as moisture low. Now we can create a get request for the same. So I'll just change this update to get, which is same as what we have over here, this statement. So yeah, so this second one is the get, and it goes with no overload. Yeah, so here we see this green symbol that a new communication has been initiated. So so that is how basically we communicate with the IoT device using the test feature on AWS IoT itself by using the subscribe and publish feature, uh, and using this topics. Now going ahead, what we can do is that we can communicate via a local device, like okay. So what do we need to do in case we have to initiate an communication with a like a remote device? Let's say I'm communicating not through this AWS portal, but my laptop Python script. So we need to go in the Act section, and we need to create a rule. Going ahead, I have a rule created over here. So I'll create a new rule. So let us create a name of this rule. That would be my RPi2 low moisture alert 2. So that is the name of the rule that we are creating. And this is the SQL query that is actually, that is how the rule actually is performed. So what we do over here is that in the select star from IoT topic over here, instead of that, we will go and copy this update accepted. So what will happen is that when my Python script from the local computer will tell this IoT device created on AWS that the uh, the moisture content is low or high, then based on that request, it will change the status over here. So I'm replacing this, and I'm setting the parameter as state.reported.moisture. as low. So if you are not able to relate what this is, this was what we used to interact with the device on the first hand. State is having two parameters inside it. One is desired and one is reported. And in the reported, we have moisture, which is either low or high. We can set it. So select star from this update accepted. That is once you are accepting an update where the moisture reported is low. So this is the rule that we are creating. And then we will add an action. Basically, what we are doing is if we see that the IoT device is having low moisture, then we will initiate some action. When this event is witnessed, then we will do some action. So I'm adding an action here. What action can we do? We can send a message as an SNS push notification. So SNS push notification is nothing but you will get a mail ID notification on your mail ID. So going ahead and configure action. So what we see here is that in the message SNS topic created here, this is fine actually. So what name we can give is that my RPI2 low moisture topic. So we are creating this topic, and for the message format we'll go with raw. And I'll create a role for this as well. My RPI2 low moisture role 2. All right. So the role is created. Now I'll add action. So this is done whenever the moisture is low, such whenever an update is received by the Python script to the AWS um, thing or device, IoT device that we have created, whenever it receives an update when moisture is low, then it will initiate that action and it will send me a mail to my mail ID. Okay, so this is the plan. Let us create the rule now. So we see that the rule has been created successfully. So we have rules here. The new rule is rule 2. So this is ready from like AWS IoT side. But what we see that we created an SNS initiation that was to send us mail um, to our mail ID. So we will need to go to AWS home page, and from where we clicked IoT core, we will click SNS once, which is simple notification service. So we are just like 2-3 minutes away from this. So yeah, so here we have subscriptions. And topics. So topics over here, you see the new second one is created. So I'll click on this and I'll create a topic. All right. The topics, I have to click this one. Yeah, so yeah, I have to create subscription. Sorry. Yeah, so in the subscription, what we have here is the protocol. So over here in the protocol, we will select email. So that is how it will send email to me, and I have to type my mail ID here, which is anampratik1998 at gmail.com. So email will be sent, create subscription. So subscription has been created successfully. Now what we see here is that it is pending confirmation. So it has sent a mail to my personal mail ID, and I'll have to click on the link over there to like confirm my subscription. So it usually happens that it goes in the spam. Yeah, so this is what we have. I'll report it as not spam so that it goes back to the inbox. Mm, yeah. So here I confirm subscription. I just clicked on this link, confirm subscription. Let me refresh this page once. Uh, I'll click on subscriptions. And yeah, we see that both of these are confirmed. One was previously confirmed. This is the new one, my RPI2. So the email is confirmed. Now what I'll do is that I'll go to the home directory where I had created this um, demo 2. Okay. Where I had downloaded all the 4 certificate files, if you remember. And the interact one is just the topics, MQTT topics. So going to this demo trial, actually I have the code over here. So I'll just copy this code. Yes. So this is actually a code that was available with the AWS documentation. So I'll just, okay, it's started to execute, sorry. Um, All right. So this is the Python code that was available with the AWS documentation as default. We have to do a few changes over here. So the first thing that you see is the shadow client, which is not to be altered. The second is host name. Host name is the one that I had uh, displayed in the AWS IoT devices. Sorry, thing. I'll just go back. I think you will be able to recollect that. Yeah. So over here, AWS IoT, we had things manage. In the things, we had this device that we had created, my RPI2, and in interact, we had this address, we can say URL. So this was how we will interact with this. So we need to have this value. So I'm copying this over here from over here and pasting it. Okay, so that is done. Going back to demo 2, what we see here is the root CA file. So you remember we had named this Amazon root CA1. No, I have not named it as the same. So I'll just rename this one over here on root. All right. So I have this file as Amazon root ca1.pem. This is txt. I should change this to pem. So just 2 more edits and this code will be set for execution. Amazon root ca1.pem is done. Private key, we see here, this is the name of the private key file. So we'll copy this value and paste it here. Okay, and this is the cert file. So cert file also we need to change. Yeah, so from here we have to copy the name and paste it here. So now we have all the changes that were needed done. The name of the device was RPi2. So I think this is all. What this code does is, I'll show it to you here. So it finds out a random value between true and false for moisture. All right, and in case if the moisture is true, then it will report status dot report dot moisture will be okay. Otherwise, that is if moisture is false, then it will report state dot reported dot moisture will be low. And if you remember the rule that we had created in AWS IoT, that rule, that SQL statement was, if the moisture is low, then send a pop-up in the mail ID that we have created, that we have subscribed to. So this code, when we execute it now, we will see the output. So I have Python. Your papers here. So we have to do this, that is install AWS IoT Python SDK. So this was something we discussed in the presentation. So I had already installed it, yes, while setting up the demo. So it was done. Now I'll execute Python moisture.py. So hopefully it works. Yeah, so what we see here is for the first time, it has created moisture value low. So it was a random selection, but for the first time itself, the value has been set as low. So hopefully there should be a mail in my mail ID, which would be a notification from AWS. And yes, we see the mail in my mail ID. This is the notification that I have received 0 minutes ago, that is right now. And this notification is because the state reported moisture is low. So whenever the moisture is low, I will receive a mail on my mail ID from the AWS device that we have created in AWS IoT, which is a thing in AWS IoT. And the Python script that we had over here is actually sending values to that update, to that IoT device. Look, like, see, we have this again low. So I think I will have another mail in my account. Yeah, I got another mail. So the code that we had over here was like, it repeats, it loops after every 60 seconds of interval. So this was the demo. Um, like right now we are just having a Python script which is randomly generating low or high value, but actually we can implement this on this Python script on a Raspberry Pi, and we can actually connect a moisture sensor, and based on the reading, like not just high or low, but some continuous reading, let us say like above 400 or below 400, so we can create that threshold 400. Whenever the moisture sensor reading goes above 400, then it will send a mail ID notification to my email ID. So this was the demo for AWS IoT. Like right now we have moisture status is okay. So I must have not received a mail. So yeah, this is the old mail. This is not the new mail. So this is the demo from my side.
Anna, is it over?
Yes, ma'am.
Thank you. Thank you so much. Masuma? Thanks for the wonderful session, Anmay. It's very resourceful.
Thank you, ma'am. I have to say a few things that first of all, I missed the timeline completely. So I'm very sorry for that. And like,
Yes,
secondly,
it's a very clear presentation. Even though it is lengthier, it is very clear presentation. Start from the beginning, scratch the IoT, and with the basics of the IoT you had started, and I saw that you made the presentation in two segments. The first segment is carrying out all the basics of IoT, how the IoT works, purposes of IoT, and the second segment was very nice, practically was useful to many of us. So it was a very wonderful session. We all learned a lot.
Thank you so much, Anmay. On behalf of VIT, we wanted to express our appreciation to you for delivering such an informative workshop and making it easier for us to understand the full stack IT development so well. Thanks for providing a clear insight of IoT, AWS, and the differentiation of IoT, AWS as server and serverless services, and talking about how IoT device testers can be used instead of microcontroller testers to test various devices simultaneously. We also got an overview about IoT greengrass, the difference between cloud-based and greengrass Lambda functions, the authentication and authorization services provided by AWS, and for giving us a live demonstration on AWS as well. It was an extremely informative session, and the participants and the participation size illustrates the importance of this topic in our day-to-day life as well. Once again, thank you so much for being a part of this workshop.
thank you. Thank you so much.
There is a
And
request
we
for all
got
the
very good
participants to
feedback.
join 30 and 2 o'clock for the afternoon session. The afternoon session, we have another eminent speaker who is going to deliver the lecture on blockchain in industry. And one more request to all the participants, please give your username in the Zoom as per the registration name, as per the details of the registration. Thank you for joining, and we will have the afternoon, we will have at 2 o'clock. Meet at 2 o'clock.
Thank you for all the participants. Anmay, we'll see later. Thank you so much.
Thank you, ma'am. Thank you.
Thank you.